Hello everyone, welcome to Abhyas IIT Prep channel. So I am Dr. Karthikeya. In this video, we are going to discuss Thermodynamics JEE Mains 2024 questions related to January phase. In another video, we are going to discuss 2024 JEE Mains questions related to April phase. So to solve the thermodynamics questions, you need to understand what is work done, heat, these are basics should be known, and different kinds of thermodynamic processes are there. So like adiabatic process, isothermal, isobaric, isochoric, and polytropic process. And in that kind of process, you need to know how to calculate work done, heat generated. Generally in isothermal means, as the name suggests, temperature should be constant. Isobaric means pressure should be constant. Isochoric means volume should be constant. And so if you know these basics, apart from that, so in different kinds of process, what I told just now, in that process you need to plot the different graphs will be there, like PV graph, PT graph, VT graph. Such kind of graphs are there, and so those should be analyzed to solve the problems. And also you need to understand how to calculate the slope in such a graphs. Okay, now going to the each and every questions that are related to thermodynamics 2024 JEE Mains January phase. Okay, yeah, first question is related to ideal gas equation is given. The ideal gas equation should also be known to solve the equations. So first thing, in the equation, PV power 3 by 2 equal to K is there. This looks like a PV power gamma equal to constant, that is adiabatic process, where gamma, if you see here, gamma equal to 3 by 2. So work done in such kind of process is work done equal to NR delta T by 1 minus gamma, or P2 V2 minus P1 V1 by 1 minus gamma is 3 by 2. So that is minus 3 by 2 is minus 1 by 2. So in the denominator, P2 V2 minus P1 V1. So this here you have to write. So then what happened? 2 into P1 V1 minus P2 V2. So this is one of the easiest question which came in the previous years, that is 2024. Just a calculation of work done. So and keeping in the answers. So another question where we have to calculate the heat given in the process, in the isobaric process. So in the isobaric process, if you see gamma equal to is given 1 plus 2 by F. So if you calculate it, so you will get what? 1.4 is equal to 1 plus 2 by F. So if you calculate this 1.4 minus 4, 0.4 by, okay, is equal to 2 by F. So 2 by 1, 0.4, F is equal to, so 5 you will get. So then heat is equal to F by 2 plus 1 into work done. So that is 5 by 2 plus 1, that is 7 by 2 into work done is how much? 200 joules. If you calculate, you will get 700 joules. That is the answer. So most of the questions are related to work done, heat generated in different kinds of process. 700 joules is the answer. Another process is isochoric process, where that is constant volume. Constant volume means work done is equal to PdV. So integral PdV. So here, if volume is constant, means work done delta W is equal to 0. Then in the first law of thermodynamics, delta Q equal to delta U plus delta W. If this is 0, what happened? Delta Q equal to delta U. He wants change in its internal energy. Okay. So delta Q is equal to, when it is only change in temperature, delta Q equal to Ms delta T. Here M is given, S is given, delta T is given. We need to get in terms of joules. That's why we have to multiply. S is given in calories. We need to multiply with J value. Then we will get this 0.08 into S is 0.17 into 4.18 into 5. If you multiply, you will get a 284 joules. This is the answer. So another question is also related to change in its internal energy, that is equal to delta Q is equal to 284 joules. This is also one of the easiest question. So most of the questions that are coming recently in the last couple of years, so physics questions are much easier compared to the previous years, so can easily get good marks. Okay, another question where it is also adiabatic process, pressure is proportional, found to be proportional to the absolute cube. Okay, then Pt power minus 3 is equal to constant. If you observe, Pt power gamma by gamma minus 1 equal to constant. This is adiabatic process thing. Then if you see gamma by gamma minus 1 equal to minus 3, gamma equal to minus 3 gamma plus 3. Okay, what you are getting? 4 gamma equal to 3, gamma equal to 3 by 4. Okay, so this is the answer. Okay, just check it. 2 gamma, this is 4 gamma equal to 3. Okay, next question is also related to this work done in the process. Work done from A to B plus B to C need to calculate. Here, see, pressure is changing, that's why I am taking average of that. Work done equal to, in this type of curve, what happened? Y is changing, X is changing. Y is this one, X axis is this one. But Y is given in dyne per centimeter square, X is given in terms of volume meter cube. Okay. So here 1 by 2 into average is 8,000 plus 4,000 into this volume change is from 3 to 7. That means 7 minus 3. So what happened? This is 6,000 into 4. This is a dyne per centimeter square into meter cube. So that is what work A to B. Okay, then work B to C is which one? Constant pressure. Constant pressure is 4,000 into 3 minus 7. Final minus initial, that is 3 minus 7, that is 4,000 into minus 4. If we add both work AB plus work BC, what will get? 6 minus 4, that is 2,000 into 4 dyne per centimeter square, 10 power of minus 5. 1 dyne equal to 10 power of minus 5 newtons per centimeter square. If you convert 10 power of minus 4 meter square into, this is meter cube. So this one cancelled, meter you will get 1. Then Newton meter is joules, 2000 into 4, but 10 power of minus 4, this is okay, cancelled, you will get a 10 power minus 1. So 200 into 4, that is 800 joules. That is the answer. Next question is also related to this PV diagram, where two processes are given. If you see the stepper curve, whenever you have given like this, stepper curve represents adiabatic process. The not that much taper is isothermal. Isothermal process means temperature is constant. That is what happened. PV equal to constant. Whereas adiabatic process is PV power gamma equal to constant. So for B, adiabatic, and for A, isothermal process, this is the answer. Simple question, right? Another question is also related to VT curve, where isobaric process means pressure is constant. If you see this, if you calculate the volume is equal to nRT by P. So we need to calculate the slope V by T, which is proportional to 1 by P. Slope is inversely proportional. Slope 1 is greater than slope 2. Okay. If you see what happened, P2 is greater, right? Somewhat greater. So P2 greater than P1 is greater than P2. So slope 1 is greater than slope 2. Okay, slope 2 is greater than slope 1. That means inverse proportional. That is P1 is greater than P2. Okay, this is the answer. So these are the questions related to January Thermodynamics 2024 JEE Mains April shift question. So most of the questions that came in the mains paper related to 2024 mains, we only got mainly the questions which are related to thermodynamic process, work done and heat generated, and simple slope calculations related to that. So as you know that we have many like 3 laws and 0th law also there related to thermodynamics. Most of the problems are related to the first law of thermodynamics. You know that delta Q equal to delta U plus delta W. So first law of thermodynamics, if you are aware, in a different kind of thermodynamic process, if you are aware, and calculation of work done and heat generated, if it is there, you can solve every question related to this mains questions previous years, okay, or general questions also you can solve related to mains syllabus. So now going to this April shift questions in this video. First question, if you observe, for a fixed temperature, so different densities are there. So for a fixed temperature, if you go through like this, so then what happened? This is there. So fixed temperature, what happened? P1 greater than P2 greater than P3. Okay, PT diagram. So you know that P is equal to N, that is nRT by V. Okay, but what happened? N, if you write M by M, okay, here V, capital M, this is molecular weight, RT. So that means P is equal to rho RT by molecular weight. So P is proportional to density. That means rho 1 greater than rho 2 greater than rho 3. Wherever it is there, I need to take that. Rho 1 is greater than rho 2. That is the answer. So this is also one of the easiest question. Hardly I used ideal gas equation only I used. From that only you got the answer. One of the simplest question which is there in this one. So next question, you need to calculate work done. Okay, in adiabatic process, if you see work done in adiabatic process, work done equal to nR delta T by 1 minus gamma if delta T is a T final minus T initial. Okay, so if you see adiabatic process, that is a TV power gamma minus 1. Okay, T1 V1 equal to T2 V2 gamma minus 1. Okay, what happened? T initial you can take volume expanded double to its 1. So V1 you can keep 3 by 2 minus 1. Here T2, T final, that is 2V power 3 by 2 minus 1. Okay, then T initial is equal to T final into this one, 2 power 1 by 2 V power 1 by 2 by V power 1 by 2. This get cancelled. What happened? T final is equal to root 2. Okay, T initial by root 2. So then what happened? Work done is equal to N number of moles. That is, so if you see nRT, okay, nRT by, okay, anywhere this I will write T final minus T initial by 1 minus 3 by 2. Okay, that is N moles, number of moles 1 if you consider 1 into R. Okay, simple sample of gas. Okay, 1 into R into 1 by root 2 minus 1 by T by minus 1 by 2 if you calculate. So you will get TR into this one, 1 by root 2 minus 1 minus root 2 by root 2. So 1 minus root 2 by root 2 into this one if you go to top, but a negative will be there. So you will get to TR into root 2 minus 1. Root 2 minus 2 you will get. You just cross check. This is the answer. Root 2 minus 2. Okay, this is the answer. You just try to calculate that one. So cut that. So this one root 2 will get minus root 2. So you multiply, you will get what happened? Root 2 into 2, that you will get. Okay, na? Negative 2 will be there. Okay. Next question. Next question is also related to heat absorbed. Okay. Heat absorbed by system is going through this one. So here, what happened here? So if you see cyclic process, okay, what happened in cyclic process? If you see, this is a circle, right? Radius you can calculate. Radius is how much? So diameter is 340 minus 60, that is 280. Radius means by 2, that is 140. So if you multiply this one, work done or heat is equal to, so P into V. Okay, what is the pressure? 340 minus 60 by 2. That is a pi r square. Okay. This is circle, right? Area, if you want to calculate, you will get that one. Heat absorbed. So pi into radius is equal 140 into 140. But one is pressure, another one is volume. Pressure is in kilopascal, that is given in kilopascal. Actually, it should be here. This should be here. 10 cube kilopascal, the pascal. In the question itself, that is wrong. And cubic centimeter. Actually, it should be in meter cube. So 10 power minus 2 for that cube. That means 10 power minus 6 meter cube. This is pascals. So 10 power minus 3. Finally, you will get, if you multiply, 61.6 joules. This is the answer. So this is one of the easiest question. Okay, in your cyclic process, what happened? These are equal. Work done, heat generated. Okay, next question. Next question is also related to heat is given 1 moles of gas. So what you need to calculate? Work done. Okay, this is monoatomic gas. This Q is equal to delta Q equal to delta W plus delta W. Okay, so work done is the heat is 48 joules. This is 1 into 3R by 2 into delta T. Delta T is how much? Delta T I'll write 1 mole of gas into work done plus delta W. Okay, work done. 48. R is how much? 8.3 given. So 3 by 2 minus, I'll write directly 3 by 2 into 8.3 into 2. Multiply it. So that is the work done. You will see 3 is 24. 24.3. 24.9 you will get. 48 minus 24.9 if you so then you will get 23.1 series joules. That is the delta work. So simple question, direct, hardly 3 steps. If you know that, so 3R by 2 because it is NCV, CV is equal to 3R by 2 for this monoatomic gas C. So NCV delta T, this is NCV delta T. That's what I substituted here. CV is 3R by 2 for the helium. So that's why we got this one. Next question is also related to, this is a cyclic process in which different paths are there. A to D is adiabatic process. And this is isothermal, this is also isothermal. AD, BC is A to D is, and B to C is this one. Okay, now TV power gamma minus 1 is constant in adiabatic process. Why I have used this one? Because isothermal temperature is constant in which process? D to C, A to B. Here A to D and B to C, this one. So just to take A to D, anything you D, because all the options are from A to D and B to C. So that's why I have taken adiabatic process. TA VA power gamma minus 1 is equal to TD VD gamma minus 1. So what we want? VA by VD. VA by VD power gamma minus 1 equal to TD by TC. So another process is also there. TB VB power gamma minus 1 equal to TC VC power gamma minus 1. So then VB by VC is gamma minus 1 equal to TB by TC. Okay, but D is equal to C. Here A equal to B. Okay, TD by, okay, then B to C. So finally what you will get? VA by VB equal to VA by VD equal to VB by VC, because these are equal. Okay, that's what. So okay, this is the answer. Okay, simple question. So only thing, if you know in the isothermal process temperature is constant, then you will get the answer. So next one, heat generated is given. So if you see, heat generated formula is equal to Q is equal to F by T plus 1 nRT. Okay, that is work done. So diatomic gas, that is 5 by 2 plus 1 for that. Okay, diatomic gas. So then what happened? nRT is 100 joules. So here gamma is given 1.4. So from that we got F. Okay, gamma is equal to 1.4 equal to 1 plus 2 by F. So F equal to 5 you will get. So okay now. Then what happened? 100 joules is given. So this is 7 by 2 into 100. That is, so what you will get? 350 joules. This is the answer. So hardly 3 steps. If you know the formula and for the diametric gas F equal to 5, so we will get the simple answer. Okay, another one is also same model which we have done previously. Work done you need to calculate. Adiabatic process only same. Work done in an adiabatic process formula is work is equal to nR delta T by 1 minus gamma. So 1 mole of gas adiabatic expansion. So another same thing what we have done for the previous things. 1 final or initial you can take final. Okay, gamma is 3 by 2. Same problem only is given 2 times in a different shifts. So T initial, V initial power gamma minus 1 is 3 by 2 minus 1 is equal to T final, V final, that is how much? Double 2 VI power 3 by 2 minus 1. So 2 power, okay, TI VI power 1 by 2 TF 2 power 1 by 2 V initial, this is V initial power 1 by 2. V initial power 1 by 2, both sides cancelled. That is the TF is equal to T initial by root 2. Work done is equal to 1 into R into Ti by root 2 minus Ti by 1 minus 3 by 2. That is minus 1 by 2. If we calculate RT into 2 minus root 2, this is the answer. That is work done in an adiabatic process if the volume expanded double to its original. So this is the answer. So just check it. Next one is also related to adiabatic process. In adiabatic process, if you see, initial volume is 5 liters, another next one is 4 liters. That one PV power gamma equal to constant. So power 1 by 5. So then if you see this, ratio of initial pressure to P initial V initial power gamma equal to P final V final power gamma. So P initial by V final he wants. That is equal to V final by V initial power gamma. So this one he wants P initial by P final equal to P final, V final is 4 by 5 power, gamma is 1.5, okay, 1.5 you will write as 3 by 2. 3 by 2, 1 plus 1 by 2 is 3 by 2, that means 4 by 5 into 4 by 5 power 1 by 2. So you can write like this, 4 by 5 I am keeping like this, 4 power 1 by 2 is 2 by root 5, so that is 8 by 5 root 5. Answer is there or not? Yes, exactly. So, if you know the equations, if you know the process, if you know the mathematical calculation, you can easily solve any type of question. So, next question, he wants net work done in this process, work A to B. General formula for work done is integral PdV, work done equal to integral PdV. So, but what is the temperature? Temperature 27. So, this is PV cube equal to RT for this process. So, then integral of P in place of this one, what you will write? P RT by V cube dV. Okay, integration from A to B. If you see, R is there. For the integration of V power minus 3 is V power minus 2 plus 1 by minus 2 plus 1. Sorry, minus 3 plus 1 by minus 3 plus 1. That is V power 1 by V square. Okay, next minus 2 plus 1 is minus 2. So you just substitute here. Temperature is 300 Kelvin. 300 Kelvin. So R is what? 8. Okay, just substitute and calculate it. It will be around 225 joules. Okay, here volume is from A to B, right? 2 to 4, you just substitute. That means 8 into 300 into by 1 by minus 2, 1 by V square, 1 by 4 square minus 1 by 2 square. You just calculate, you will get 225 joules. That is from work AB. Next one, I'll write here. Work BC is what happened? same integral PdV, but pressure is constant, that is 10 into 2 minus 4, that is minus 20 joules. Newton per meter square directly given, volume meter cube. So Newton meters, that is joules. Work CA. CA is equal to, what is this? Here volume is fixed. That means 2 minus 2, that is into pressure. Pressure is changing. Okay, if you take average also, in isochoric process volume is 0. That's why total volume, total work done is equal to net work is equal to work AB plus work BC plus work CA. So that is 225 minus 20 plus 0, that is 205 joules. This is the answer. So simple questions. Only thing, you need to understand different kinds of process, how to calculate work done, heat generated in different kinds of process. If you know the concept, you can solve any type of question. So that's it from this video. So we have calculated easily. So I hope you enjoyed the session. Thank you. All the best.